My name is Armel Castellan. I'm a warning preparedness meteorologist with Environment Climate Change Canada. I want to start this meeting, this briefing in a good way. Both Nathan and I are speaking to you from the unceded traditional territories of the Lekwungen and Wasanic peoples. Next slide, please. What I'm showing you here is an example of what happened in the month of May. You can see some very strong red coloring, signifying the anomaly of the temperatures that were seen across Western Canada, particularly over the territories, Northwest Territories and Nunavut, and Northeastern British Columbia and the prairies. Now, it's important to understand where we have been before we understand where we're going. So actually, this story starts back in fall of 2022, when, of course, we had also very warm conditions in September, October, and very dry conditions then as well. And now we've gone through the spring, which was actually quite cool in April and March and April, and became extremely warm in the month of May, as you can see with this diagram on the screen. Next slide, please. Now, looking at the precipitation signal, this is also an anomalous chart showing the blue with above amounts of precipitation in millimeters, and in red, orange, and yellow, below amounts of precipitation, again in millimeters. As you can see across Canada, from coast to coast to coast, with the exception of northwestern BC, Yukon, as well as parts of Ontario, most of the country is shaded in yellow or deeper orange, in particular Nova Scotia, eastern Quebec, right through the prairies, including northwestern Ontario, and a big part of British Columbia. And this is true not just for 1 month, but for March, April, and May. So a very long period of time to have little in the way of precipitation. And again, this is also true when we look back several seasons, including the fall of 2022 in particular. Next slide, please. Now what I'm showing is the forecast, and what we're looking at here are probabilities of the temperatures being in a different category. The blues are below normal or low seasonal. The gray and purples, which there's very few of, are for near normal, and of course the yellow, orange, and reds are for above seasonal temperatures. So the probabilities, as you can see, for mid-June to mid-July are extremely high over Quebec and Ontario, Manitoba, and even edging all the way over to the West Coast, with the exception of maybe parts of Vancouver Island. The only areas in the entire country that are forecast to have below seasonal temperatures over the coming months are for up in the north near Baffin Island, Ellesmere, as well as the Avalon Peninsula. Next slide, please. What we're seeing here are the same type of probabilities, however, they are for the entirety of July, August, and September. They look very similar in that Ontario, Quebec, the northern prairies, northern BC, and up into the territories show some very high probabilities of seeing temperatures that are, again, in that above seasonal or above normal category. And so these were produced on the 15th, just 5 days ago, and are actually agreed upon by many international models that show a similar seasonal forecast. Both the Americans, the Europeans, and any number of other meteorological agencies across the planet. Next slide, please. So before I leave you with the tools, I would like to say that the seasonal outlook provides an opportunity to identify potential risks and therefore better prepare and respond to extreme weather events. Canadians have experienced a hot and dry spring. Current seasonal forecasts suggest the anomalously hot conditions will continue across the country this summer. Potential consequences of this seasonal forecast include high frequency of wildfires that may exceed local management capacity, evacuations due to fire and poor air quality from smoke, potential for heat waves that create health risks and contribute to mortality for vulnerable communities, as well as the potential for continued drought conditions. So please stay weather aware and follow us on our various channels, including the WeatherCan app, on our online presence at canada.ca/weather, of course, on social media, on Twitter with ECCC weather, and then the two-letter number or letters for the province or the territory. We have, of course, Hello Weather and Weather Radio. So with that, I will leave you with Dr. Nathan Gillette with the Science and Technology branch. Nathan.
Thank you, Armel. Next slide, please. So I'm going to talk to you about how climate change affects extreme weather events in Canada. For one example of this, we can think back to the June 2021 heat wave, where a new record temperature was observed for Canada of almost 50 degrees Celsius. We've carried out event attribution studies on that heat wave, and we find that that event would have been almost impossible without the effects of human-induced climate change. So climate change is already having effects on extreme events in Canada. This graph shows the cost of natural disasters in Canada over the last 40 years, and climate change is one of the factors that's contributing to an increase in those costs. You can see, for example, the costliest event in the record is 2016, corresponding to the Fort McMurray wildfires, which the fire weather associated with those has been found to be made much more likely by human-induced climate change. So changes in extremes cause growing economic losses, social disruption, environmental damage, and loss of life in Canada. Next slide, please. How do we go about linking extreme events with climate change? Well, we can do this with an approach called event attribution. And the idea here is that we can establish a distribution of an event of interest in the current climate with the effects of human-induced climate change. And that's represented schematically here by the red curve. This would come from climate model simulations. And then we can compare that with the same distribution without the effects of human-induced climate change, and that's shown by the blue curve. And then for an event of interest, shown by the black line here, we can calculate the probability of an event at least that strong in the current climate, and we can compare that with the probability in a climate without human influence, and that allows us to quantify the effects of human-induced climate change on a particular extreme event or class of extreme events. Next slide, please. For an example of that, this slide shows the results of an attribution of area burn in BC forest fires. The graph on the left shows the area burned in southern BC in green. You can see that there has been an increasing trend in area burned in this region over the period of record. You can also see that this variations in the area burn are well explained by variations in July temperature, shown here by the purple curve. And climate change is one of the factors driving changes in area burn, and it's an important factor. And so based on this relationship, we can infer how much climate change has affected the area burnt in BC. And this study concluded that human-induced climate change has increased the area burnt in southern BC by a factor of between 7 and 11. So a big influence there of climate change on wildfire in BC. Next slide, please. But we can use climate models not only for attribution, but we can also use them to help us make projections of how extremes will change in the future in Canada. The example on the left is taken from the last IPCC assessment report from a chapter actually led by one of our scientists in Environment and Climate Change Canada. So this shows how a 1 in 50-year heat wave in the pre-industrial climate, or in the late 19th century, how the frequency of that event has changed over time. And this is a global average. But in the present climate, with a little more than 1 degree global warming, this kind of 1 in 50-year heat wave is now about 5 times more likely to occur. With a 1.5 degree C level of warming, this will be expected to occur around 9 times as frequently as in the pre-industrial climate, and at 2 degrees Celsius global warming, substantially more frequent, about 14 times more frequent than in the pre-industrial climate. So climate change is already affecting Canada. It's already affecting extremes around the globe. That there's a certain amount of further change that's inevitable, even if we are successful in reducing emissions to net zero by the middle or latter half of this century. But if we're not successful in an unmitigated climate where emissions continue to increase, we could expect about 4 degrees warming by the end of the century. And in that scenario, we would see that 1 in 50-year heat wave become something that we would see almost every year by the end of the century. So still a big difference between a climate where we're able to mitigate, where we're able to get emissions to net zero, and a climate in which the emissions continue to increase. And finally, this information on changes in extremes from climate models is also very useful for informing adaptation, for helping us make better decisions to adapt to climate change. As one example of this, our department has used information on changes in extremes to inform future building codes in Canada, as shown by this report here. So that concludes my part of the presentation. Thanks for your attention.